Welcome to The Explainer. Today, we're diving into something that sounds, well, a little crazy. A practice that seems destructive on the surface, but is actually one of the best ways to build systems that don't just survive failures, they actually thrive in the chaos. So, let's just jump right in with a question that probably keeps a lot of engineers up at night. In the super complex, distributed systems we all rely on these days, this isn't some hypothetical what if. Nope, this is an expected, almost inevitable part of building software today. And the cost when things do go wrong? It's staggering. We're talking as high as $16,700. And that's not per hour or even per day. That's per server per minute. When you're looking at numbers like that, building systems that can handle failure isn't just a nice to have for the tech team. It's a straight up business necessity. Okay, so if the stakes are that high, you've got to wonder, right? Why aren't our normal testing methods catching this stuff? Why can't they stop these super expensive outages? That's the big question we need to unpack first. It really boils down to a huge difference in mindset. Think about it this way. Traditional testing is reactive. It's all about confirming that the things you already know about work the way you think they should. But chaos engineering? That's proactive. It's like going on an expedition to find the hidden weaknesses, the things you don't even know you should be looking for. In this table here really lays it all out. What's so interesting is you see traditional tests are usually run in these perfect, sterile, lab-like environments. They look at one little piece at a time. The problem? They totally miss the messy, domino effect failures that only show up in the wild, in actual production. So you've got this huge gap, right, between testing in a clean room and the absolute chaos of reality. And that gap is exactly why we need a totally new way of thinking, a new way to build real confidence in the systems we depend on. All right, so let's break down this definition. The two words you really got to focus on are deliberately and uncover weaknesses. This isn't about just, smashing things randomly and hoping for the best. No way. It's about running carefully controlled, scientific experiments to see exactly how your system reacts when things get tough. And the payoff? Well, the results pretty much speak for themselves. When teams start doing this, they see real, measurable improvements. Things like a lower MTTR, that's mean time to recovery, basically how fast you can fix something, and a lower MTTD, or mean time to detect, which is how fast you can even find the problem. And all of that adds up to what we all want: more uptime, fewer bugs, and way less downtime. So how do we actually do this? How do we take this idea that sounds a little wild and turn it into a structured, disciplined process that genuinely makes our systems tougher? Well, it all boils down to a core set of principles. These 5 principles right here, they're the bedrock of the whole thing. They prove that this is a real science, not just random destruction. You always start by defining what normal looks like for your system. Then you introduce a very specific, controlled failure. You watch what happens, and, this is key, you do it all while making sure you limit the blast radius so the experiment can't cause widespread problems. And this diagram really shows you that it's a cycle, something you do over and over. It's basically the scientific method, but for making systems more reliable. First, you figure out your baseline. Then you form a hypothesis, a guess about what will happen. Then you run the experiment, you introduce that disruption. And finally, you take what you learned and use it to make the whole thing stronger. Okay, so that's the theory. But let's talk about the real world. How does this actually play out? Because this isn't just some academic idea. Some of the biggest tech companies you can think of basically invented this stuff because they had to. And yeah, it pretty much all started with Netflix. They had this completely radical idea to build a tool they called Chaos Monkey. What did it do? It would literally just roam around their live production system and randomly shut down their own servers. I mean, talk about the ultimate test of resilience, right? And what they proved was absolutely crucial. You can't just test for failures every once in a while. The big lesson from Netflix is that if you want to build one of the most reliable platforms in the world, you have to make failure testing automated and continuous. It has to be this constant check-in, always validating that your system can handle whatever gets thrown at it. Then you've got Amazon. They saw this and basically built the whole concept right into the DNA of their cloud platform, AWS. They created tools like the fault injection simulator, which, essentially gave the power of chaos engineering to everybody. Thousands of companies can now use it to test their own stuff. And their big contribution was showing how you can use chaos engineering to actually design better systems from the ground up. The huge takeaway from Amazon is this: design your architecture to physically contain that blast radius we talked about. That way, a small problem in one corner can never ever snowball into a massive global outage. And then there's Uber. Their system is this unbelievably complex web of little services all talking to each other. And they run these chaos experiments all the time, even during rush hour, to make absolutely sure that the critical stuff, like matching you with a driver or taking your payment, just works, no matter what. So the lesson from Uber is all about testing the connections between those different services. If one little piece has a problem, does it set off a chain reaction? That's the question they're always asking. Their whole philosophy is about finding and fixing those hidden weak links before they ever have a chance to affect you, the user. Okay, so seeing how giants like Netflix and Amazon do it is really inspiring, but it can also feel a little intimidating, right? So the big question is, how can you start bringing this into your own world, but do it safely? Now, before you even think about starting, it is so important to know the common mistakes people make. Remember, the goal here is structured learning, not just creating chaos for the fun of it. If you run experiments without clear goals, or without watching what's happening, or without safety nets, well, that's just a recipe for disaster. And this table here shows the golden rule for doing it right. Start small and scale up gradually. You don't jump into the deep end. You start with something simple, like maybe shutting down a server in a staging environment where no real users are. Then, once your team gets more confident and the system proves it can handle it, then you can slowly move on to bigger tests, maybe on just a tiny slice of your real traffic. And if you follow these best practices, you can make sure that every single experiment you run is a valuable chance to learn something. You know exactly what success looks like, you keep the impact small, you automate things so they're repeatable, and, this might be the most important part, you write down what you learned and share it with the team. That's how the whole system gets stronger. At the end of the day, chaos engineering is really about a huge shift in culture. It's about moving away from a world where we're terrified of failure and try to prevent every little thing from going wrong, and moving toward a world where we accept that failures are just going to happen. And because they're going to happen, we focus on building systems that can take a hit and keep on going. Which leaves us with one last thought to chew on. Is your system designed just for success? Or is it only designed for the sunny days? Because real resilience, real strength, isn't about just hoping for the best. It's about being ready for the storm.